Welcome to the first ever video for Maths Guide. Today I'll be telling you about the basics of matrices. Okay, so firstly, before we start off, we have to ask ourselves, what is a matrix? A matrix is simply a set or an array of numbers used to easily represent something. Okay, so let's say we got this for starters. Okay, this is a matrix, and we call this a 2 by 2 matrix. Why? The reason is because the first number represents the number of rows, and the second number represents the number of columns. Okay, so in a matrix array, the row is always the one that is horizontal. Remember, that's going from left to right. That's the row. And as for the column, it is whatever that is going from top to bottom. So in this case, we have 1, 2. So 2 rows, 1, 2, 2 columns. So we call this a 2 by 2 matrix. So let's say if we got something like this. Okay, so this will be called a 2 by 3 matrix because it has 2 columns, row, 2 rows and 3 columns. This is a 2 by 3 matrix. So moving on, now I'll go on to the properties of a matrix. So firstly, it is that matrices are commutative. Okay, what does this mean? Matrices are commutative. So what it means is that matrix A plus matrix B will always be equal to matrix B plus matrix A. So what it means is that the order in which who comes first and who comes later doesn't matter for the matrices if you add them together. Okay, so if you add A plus B, it'll still be equal to B plus A. Okay, so let me show you an example. So let's say that for A we got 1, 2, 3, 4. Okay, and for B we have 5, 6, 7, 8. So for A plus B, what we just do is we add the numbers that are in the same position forward. So in this case, first row, first column, okay, 1 plus 5, you get 6. So second column, first row, 2 plus 6, we get 8. Second row, first column, 3 plus 7, you get 10. And lastly, second row, second column, 4 plus 8, you get 12. So this is what we call the matrix A plus B. So let's see if we have B plus A what would you get? First row, first column, 5 plus 1, 6. First row, second column, 6 plus 2, you get 8. Second row, first column, 7 plus 3, you get 10. Second row, second column, 8 plus 4, you get 12. So it is shown that the arrangement doesn't matter whether A comes first or comes second. So that's it. That is what we meant when we say that matrices are commutative. So on to the second property. Matrices are associative. Okay, what does it mean? Let me write it down for you guys. So, as you can see here, it doesn't matter which we add first. Let's say, for example, we have B plus C, we add them up, and later on we add A. It will still be equal to if we add A and B first and C later on. Okay? So, let me show you another example. So we'll take the A from the previous question, B from the previous question. So let's say okay, so in this case we'll add up B and C first. Okay, so what we'll get is 1, 2, 4, and if we add up B and C, first row, first column, 14, first row, second column, 16, second row, first column, 18, second row, second column, 20. And if we add this up, what we'll get is 15, 18, 21, 24. So this is what we get for the first one. Let's try the second one. From the previous question, we saw that A plus B is equals to 6, 8, 10, 12. So let's write it down. Okay, and let's add C. 9, 10, 11, 12. And what we will get here is first row, first column, we'll get 15. First row, second column, we get 18. Second row, first column, you get 21. Second row, second column, 24. And as you can see, they are both the same, and hence we say that matrices are commutative, associative. Okay, that is all for today. we'll proceed on towards matrix multiplication in the next video. Thank you.